Hello friends, welcome to the next session. We are going to do the fourth problem on push-down automata, and the problem says the language is a raised to 2n b raised to n where n's value is greater than equal to 1. So let's get started. So friends, if you observe this problem, I'm very sure after giving a thought on this problem, you all might have realized that this problem is very similar to the second problem that we solved on the push-down automata. Yes, you are absolutely right. So as per that logic, you will be saying that for every two A's, we can say push 1x, and for every B, pop 1x, right? So now let me write down the logic. I say over here, for each of the two A's, push 1x on the stack, and for every B, pop that 1x from the stack. Let us try to understand the problem in more detail now. So friends, if I say I am having the input as n equal to 3, so that gives me 6 A's followed by 3 B's, right? So now going ahead, 6 A's followed by 3 B's, and I have a stack with me. As usual, the stack has bottom as my R, and now how are we going to evaluate the thing? So logic says for each of the 2A push 1x. So maybe I receive a. Am I going to push anything onto the stack? No, right? Because the logic says for each 2A's push 1x. So what are we going to do? As we did in the third problem, have a state change. So maybe I'm in state Q0. I receive a. I say do not do anything onto the stack and simply change the state to Q1, right? Then once you receive one more A, I say go back to Q0 and push X above that R. Now this thing is going to repeat for this A having one X pushed. Similarly for these two A's having another X pushed, right? Going further ahead, for the first time when you receive a B, now we all know that we are going to have a first pop operation, and therefore I say B comma epsilon, and I am in state Q2 that pops my first X. Further, when you receive the second B, the pop operation is going to be repeated. So I write B comma epsilon over here and X will be popped. The moment you receive third B, again Q2 will have a cyclic transition and third X will be popped. Ultimately, you will be having a epsilon as the input. If the stack top is R, I say let's go to the final state and conclude that the PDA is going to accept that input. So with this in mind, let us solve the problem. So friends, I have my stack over here now. The bottom of the stack, as usual, I am populating with R. Going down to my rule where I say del, and the input we are accepting is A, B, B, right? So I'm taking n's value as equal to 2. So I'm in state Q0, input symbol is A, stack top is R. In that state, I say simply have a state change and do not do anything onto the stack, and therefore I say go to Q1 and the stack remains with R. Further, I receive in state Q1 my second input A, but this time the stack symbol is still R. But one thing is guaranteed over here, that when Q1 receives a A, it is guaranteed that it had received a A previously in Q0. That's the reason it is in Q1. So I say over here, go back to Q0, push X above that R, and let's have the operation having effect in the stack now. Going ahead, before that, this is going to be my operation for first two A's. Going further, I receive the same thing for 2A's and I have to push one X over here. Let's see how the things work. I am in state Q0. I receive a, but the stack top is currently X. I'm talking for the third A. So I say go again to state Q1. Do not touch anything onto the stack. Therefore Q1 comma X, and the stack remains as it is with only a single X pushed, of course. Going further ahead, I am in state Q1, input symbol is my fourth A, stack top is X, and we say simply now go to Q0 and perform a push operation on the X. Now X is going to be pushed onto the stack. And this operation will be repeated for all of the remaining 2A's in the similar fashion. So this is done, and now for the first time the machine is going to receive a B and it will be in state Q0. So Q0 on receiving B, when the stack top is X, I say over here perform pop operation for the first time. That takes me to the state Q2 comma epsilon, and this X will be popped out from the stack. Further, I am in state Q2. I receive my last B as per the example. Stack top is still X. I say keep on popping all the remaining B's in state Q2 itself, signifying this is for my first B and this is for my remaining B's, right? Further, I now have epsilon after this. So I say Q2 on epsilon when the stack top is R goes to QF comma R, and conclude that the FSM is going to accept this. Now the last step is always going to be repeated, right? The same thing we are going to write it. Only the thing which is going to change is Q2 or Q1 will be there over here. The rest everything remains the same. Now friends, with this in mind, let's do a problem on the same. So my example over here, I start, let these my rules be 1 2 3 4 5 6 7. Let us consider the same example. So I say I am in state Q0. I have 4 A's with me, I have 2 B's with me, followed by a R. Going ahead, Q0 on A when the stack top is R, using rule 1, go to Q1, you have 3 A's, 2 B's and R. Q1 on A when the stack top is R, as per rule 2, go to Q0 back, I have 2 A's, 2 B's and a X pushed above the R. Q0 on A when the stack top is X, as per rule 3, go to Q1. I have A, B, B on the stack and stack remains same. Then I have Q1 on A when the stack top is X. I say go to state Q0, you have BB with you and one X will be pushed above the R. Then I have Q0 on B when the stack top is X. Using the rule 5, perform the pop operation by going to state Q2 for the first time. I have single B left over here and XR. I'm writing over here. Then Q2 on B when the stack top is X. Keep on popping in state Q2. You have epsilon as the input and R as the stack input topmost symbol. Then Q2 on epsilon when the stack top is R, I say go to QF comma R, and since I have gone to QF, I say I am going to accept the input. So with this we complete this problem. See you in the next problem. Thank you friends.